So, hello, good day to you all, and welcome. This is our presentation of our research proposal. I'm Alson Jerusalem, and together with my research partner, Mr. De Castro.
Hi guys, my name is Ryan Paul de Castro, a third year electrical engineering student of Negros Oriental State University College of Engineering and Architecture.
And together, we will showcase the idea that we came up with, and we will explain this idea through the course of this presentation. So, alright, let's start. So, our study is titled Solar Powered Electric Scooter. So, hearing the title, I think you can have the idea that this is about scooter that is powered using solar energy. So, this is chapter 1, the problem and its scope. It is an inevitable future that automobiles are shifting to the efficient use of electricity as a power supply. Electric scooter is a product of this innovation. Its purpose is to have efficient yet low-cost means of transportation. Just give it a good charging session and it'll be ready to go. The use of electric scooter eliminates the high cost of maintenance in gas, oil changes, and repairs. Because electric scooters are powered by rechargeable batteries, therefore it has no emission and is more environmental friendly than a gas-powered automobiles. However, its usage of electrical energy alarms the inadequate supply of electrical energy in the long run. The problem of electrical supply might be compromised when electric automobiles start to emerge. The continuing escalation following the development of more electric automobiles points to the demand for the use of alternative source of energy. The discovery of using solar energy to supply electricity demands can be convenient in addressing the problem of electrical supply. The idea of developing electric automobile combined with the technology of solar energy source can be a solution to address the increasing needs of supply. Solar energy system or photovoltaic system is a power system designed to supply usable solar power by the means of photovoltaic reaction. It consists of an arrangement of several components, including solar panels to absorb and convert sunlight into electricity, a solar inverter to convert the output from direct to alternating current, as well as mounting, cabling, and other electrical accessories to set up a working system. One way to do this is to adapt solar energy technology to the modern electric scooters. Embracing solar energy technology is the best option for electric scooter because it lessens the cost of consuming electricity from the conventional source of charging it.
Statement of the problem. Electric scooters are one option for commuting, especially in hassle traffic and crowded places. It can run up to 20 to 30 kilometers per hour and it's powered by electricity. It is charged and consumes electricity. Attaching solar powered source is an efficient way of using renewable source to power the scooter. It would help reduce the electric costs it consumes by creating its own electricity. This study aims to provide answer to the following question. Number 1. What is the ideal solar panel capacity that can be installed in the electric scooter? Number 2. What would be the estimated cost in the installation of solar panel in electric scooter? Number 3. How many hours can an electric scooter use to power the solar panel provides? Number 4. How much electrical power the solar source can provide? And lastly, what is the estimated power savings the solar power source used to compare to the conventional power the electric scooter uses?
So, this is the significance of the study. The result of this study will be beneficial to the following. For the people, this study helps to reduce every financial burden of the people, especially if they are using the scooter in traveling in different areas for their respective works. Electric scooter minimize the cost of usage in gasoline and instead relying to the solar panels of the electric scooter. For the environment, this study will benefit the environment given the growing concern of air pollution and climate change. We all know that sunlight or solar energy is clean and is free. The use of solar technology has no harmful effect to the environment and it is very environmental friendly. For the researcher, this study helps especially to the students and future researchers who are studying related to the study of solar energy. It talks about more concern and principle of the solar energy and how it is used in our daily lives. There are also references that help them to know more about solar energy.
Scope and limitation of the study. This study is limited for the people who are using motorcycles and scooters as mode of transportation in doing their respective works daily. According to the source of researchgate.com, access to direct sunlight is needed for solar panels to performance at their best. Often, commercial installing of solar panels will readjust during the day to maintain an angle that provides them with direct sunlight, best for converting into energy. However, most homeowners simply mount solar panels in a rigid, fixed position, which means that the panels only have access to direct sunlight for a limited amount of time each day. Theoretical framework of the study. This study is about understand the state of art of photovoltaic solar energy through a systematic literature research. According to the article of Georgia Apostol about the existence of solar energy, in which the following themes are approached: ways of obtaining the energy, its advantages and disadvantages, applications, current market, costs and technologies according to what has been approached in the scientific researches published until 2016. For this research, it performed a qualitative and quantitative approach with a non-probabilistic sample size, obtaining 142 articles published since 1996 to 2016 with a slitting cut. The analysis result of this research shows that studies about photovoltaic energy arising may perform an important role in reaching a high energy demand around the world. To increase the participation of photovoltaic energy in the renewable energy market requires, first, to raise awareness regarding its benefits, to increase the research and development of new technologies, to implement public policies, a program that will encourage photovoltaic energy generation. Although crystal silicon solar cells were predominant, other types of cells has been developed which can compete both in terms of cost reduction of production or in terms of greater efficiency. The main applications are dominated by telecommunications, water pumping, public lighting, BIPV, agriculture, water, heating, grain drying, water desalination, space vehicles, and satellites. So, here is the simplified chart explaining the source of power used by the solar scooter. So, solar energy from the sun direct to the solar panels of the scooters. These figures show the simplified concept of how the scooter works by using the source of solar energy through the use of solar panels. According to the studies that found that photovoltaic solar energy are all technical, thus creating the needs of the future research related to economical viability, chain supply coordination, analysis of barriers and incentives to photovoltaic solar energy, and departs studies about the factors that influence the position of such technologies in the system, especially in transportations just like motorcycles and scooters.
So this is the conceptual framework of the study. So the concept of the study is to utilize solar technology to harness efficient energy from the sun to power an electric scooter. This paves a way of creating a free and clean electric power source. Compared to other scooters that are still using the conventional fuel to power its motor, electric scooter is much environmentally friendly. So this is the initial design of our project. So this is the electric solar scooter that we want. So as you can see, at the front side of the scooter, there are three sliding solar panels that are mounted at the front side of the scooter, and the battery is located underneath the floorboard of the scooter. We think solar scooter is efficient this way, and this is the idea that we came up with.
Review of related literature. There are many literatures and studies that relates to the study of solar energy, especially in using PV solar energy technology in transportations. According to the study of Yinli Chen about the application study in solar energy technology for a highway service area, as case study of West Lushan Highway Low Carbon. Development and utilization of green energy are one of the most important energy-saving measures. Many technological industries promoted the importance of development of solar technology. It was also said that solar energy was used in application of solar energy in Europe in the fast pace, and the use of solar heat is more extensive, involving power generation, domestic hot water, heating, local heating water, and so forth. More than 90% of the solar heat is used for the residential areas in the EU. According again to Chen, China began to use solar energy early in the 1970s, achieving good results in the beacon lights. In the 1990s, solar photovoltaic technology began to use in road lighting and signals, and solar water heating systems entered the rural residential areas under the support of China government by the late 20th century. In the 21st century, solar photovoltaic technology has been greatly promoted by the growing attention of government and the improvement of solar cell production technology. Windmill solar energy application field also expanded gradually. In the website on Razor, it stated that reasons on why electric scooters are convenient and better for the environment. It says that based on the Yale survey map, 70% of Americans care more about the environment and the carbon footprint they living than the economy. This demographic that people want alternative transportation options in addition to other eco-friendly choices. Electric scooters fit the bill for anyone who wants to get around quickly without a high cost or harm to the environment. In the article of an overview of existing experience with solar-powered e-bikes by Georgia Apostol, Angel Reinders, and Cars Gears, electric bicycles or e-bikes are considered a sustainable alternative to automobile transportation today. The electric bike includes all the benefits that conventional bicycles offer, plus faster, more comfortable, and longer trips, as well as less effort for the user. In this paper, we specifically focus on a new type of e-bike, the so-called solar power e-bike.
Research methodology. The use of the solar panel depends on the battery rating that is used by the electric scooter. To optimize the potential use of the battery, it is needed to determine its capacity in terms of ampere hour and the voltage it can produce. So figure 3 present the solar panel in terms of watts rated with watts, and solar battery rated in terms of ampere hour. So in order to give an estimated value, the daily energy harvest of the solar panel and the energy needed for the battery was calculated using this formula. So the first formula is the daily energy harvest of a solar panel. So daily production in terms of watt hour is equal to watts times 4.5 hours, where watts is the number of watts that a solar panel can provide, and 4.5 is the peak sun hours in the Philippines. The second formula is the energy needed for the battery. So energy needed, the in terms of watt hour needed, is equal to ampere hour times the voltage, where ampere hour is the ampere hour of the battery rating and voltage is the voltage the battery can provide. But since we cannot use the 100% charge power of the battery, we need to apply the depth of discharge, or the DOD, which multiply the watt hour needed to 50%. It means you can only use half of the battery rated capacity. Therefore, the formula then derived to watt hour needed is equal to ampere hour times voltage times 50%. So the use of the formula that was given is to check if the scooter battery and the solar panel are compatible with each other. We have an example situation here. So we are given with a 12 volt system with a 100 ampere hour scooter battery and a 200 watt solar panel. Now let's check if the two are compatible to use. So to compute the energy harvest, watt hour needed is equal to 100 ampere hour times 12 volts. 100 times 12 is equal to 1200 watt hour. So 1200 is the maximum energy that the battery can store. So 1200 is the maximum energy that the battery is needed. But since we cannot use all of it at once, we need to apply depth of discharge, or the DOD. By applying DOD, we need to get the 50% of 1200. So 1200 watt hour times 50% is equal to 600 watt hour. So we can now assume that this battery with 12 volt system and 100 ampere hour only needed 600 watt hour of energy. So now let's compute the daily energy harvest of our 200 watt solar panel. So the daily energy harvest is equal to 200 watts times 4.5 hours. So 200 times 4.5 is equal to 900 watt per watt hour. So 900 watt hour is the maximum daily energy harvest of our solar panel that has 200 watts. Since the battery only needed 600 watt hour energy, therefore 900 watt hour of a 200 watt solar panel is more than enough to supply the battery needs and is very compatible with the battery. But remember, if a solar panel cannot supply the battery, or it has a lower energy production than the battery needed, then therefore it is not compatible for the battery. To ensure the safety of the battery and avoid overcharging, a solar controller is attached in order to regulate the flow of energy coming from the panel. So figure 4 present how the solar panel, the solar controller, and the solar battery are being mounted. So the solar controller is placed between the solar panel and the scooter battery. Before the energy go to the scooter battery, the energy that was harvested by the solar panel will go through a solar controller in order for the energy to be regulated and to be suitable for the scooter battery needs. So that was our research proposal. I hope you learned something from it, and thank you for giving your time to listen and watch this presentation of ours. And again, thank you and have a blast, have a good day.